Thank you so much for the introduction and the invitation. I really would love to be with you there in person to discuss about this important topic globally related with aquatic aquaculture and the importance of GIS and epidemiology. Over the years, I've realized that aquaculture sustainability is largely influenced by the spatial density of farms. In many places that I've been, I had the opportunity to explore the epidemiology of infectious diseases. The key factor that appears is the spatial characteristics of the distribution of the farms in different settings. Um, we will see that spatial structure is actually a key primordial level of prevention for many infectious diseases. Preventions means different intervention levels that I will show later that are related with this primordial, which is the spatial structure. So clearly, to achieve sustainability, to achieve health management, you need to have an understanding precisely about the spatial distribution, and that's required the application of spatial techniques to assess and quantify risks. My experience is related with an infectious salmon anemia epidemic, a viral diseases that affected the industry in my country, in Chile. And I didn't realize the impact of an outbreak, including notes in very important newspapers like the New York Times, Wall Street journals, scientific journals like Science and Nature, all uh, reviewing the impact of the disease, which is not only fish death, is related with the ecosystem, is related with the food security, is related with the economy of the whole country. And as I will show you, the epidemic of infectious salmon anemia was clearly an example of how the spatial structure of the industry at that time was determinant in the final outcome, which was estimated about $6 billion and lasted from 2007 to 2009. I hope you can see this, but this is an example of the distribution, the density of the distribution on farms in Chiloé Island in Chile. This is another example of farms, trout farms in Puno, Peru. See how dense are those settings. In Betania, Colombia, where I just recently visited, this is a dam that is now used for tilapia farming and is important hub for production in Colombia. But again and again, you will see these high dense and hyper-connected farms between one another. And even in Sinaloa, Mexico, where I also had the opportunity to work with shrimp farms, you again see this, which is not only about the space, has also challenges about how do you define an epidemiological unit of interest. Because here, for example, you focus on a pond, which is the basic unit for production of shrimp. The pond is highly connected with many other ponds within the farm and between farms. So here, for example, the epidemiological unit is really, really something challenging to define, to study further. Most disease transmission depend on the spatial structure. This is a work from Birgit in Oiman, and she, described the different ways that of farms of a population of fish can be infected by primarily water and processing plants, wild animals, mechanical transmission, for example, share equipment or personnel that move between farms, and movement of aquatic animal, which also brings another aspect of the spatial epidemiology, which is network analysis, for instance. So, but here, water is likely the higher risk by most. Um, Here, for example, while in Chile, we pretty much discussed that the critical disease threshold distance between farms is about 10 to 13 kilometers. That means that between 10 to 13 kilometers, the risk of infection from one farm to another is very high. We have several studies on infectious salmon anemia, sea lice, infectious pancreatic necrosis virus, PC rickettsial salmonis, and all of them are around those estimates, except for sea lice, because sea lice is a parasite that has a larvae stage of free living stage in the water, which makes that much even more complex because it can survive for longer periods of time. In Norway, for example, the highest risk for fish disease from other families within 20 kilometers, in the same line pretty much, and this is based on different estimates from pancreas disease, heart and skeletal muscle inflammation, and other like sea lice and infectious salmon anemia. This is very important because, as I mentioned before, in the epidemiological way of thinking, you need to uh, determine um, primordial, primary, secondary, and tertiary levels of prevention in order to effectively manage disease. Most of the time, I will start from your right to the left. Most of the time, when you discuss with the farmers and with the producers what is the important aspect of the controlling disease, they will focus on antimicrobial use or any other technique like cooling or whatever is the intervention in the tertiary way. That's mean measures that prevent new outbreaks, which is only makes mitigation of disease impact. If you discuss further, they will say, well, yes, but uh, you ask what is your secondary intervention level, which is related with the early detection, for example, the screening or early diagnosis to perform an adequate treatment. And then you become in the whole field of diagnostic test performance and the importance of that early detection, which also doesn't reduce the number of new cases, but reduce prevalence, the burden of the disease, and this is called preventive medicine. Even before the um, secondary, where you don't have a disease, you focus on primary intervention level. And this is all action taken prior to the onset of disease. And this is clearly something more important than the other two because you can reduce the incidence. Examples, vaccines, examples, genetics, all of those before the onset of the disease are primary intervention levels. And even before that, you have primordial intervention level. And this is where spatial plays a role. You are targeting the underlying condition that lead to causation. Here you prevent risk factors for the development of the disease. And this is where spatial epidemiology plays an important role. You can translate these levels for anticipate, prevent, detect, and respond. Most of the time in the discussion with the farmers, they are responding, detect, respond, but really not doing prevention, not even doing anticipation, which is, again, a core part of the spatial planning, for example. In epidemiology, well, in veterinary medicine, which is my background, you have a traditional perspective from the animal to study the animal, then the organ, tissue, cells, and the molecule. This is the traditional way that you teach veterinary medicine, and in this case, related with fish. So you have a fish, you do the necropsy, then you open the fish, and then you take samples, and then you make the diagnosis. But in epidemiology, we start from a population perspective, from the animal, the fish, then the farm, the area, the whole country or the region. But in each of those different stages, you may have different application of spatial techniques. For example, from the genetic side, from the genetic structure of the pathogen, or even the aquatic animal, spatial population structure is something that is called phylogeography sometimes, when you match together geography with phylogenetic studies. Of course, visualization, disease mapping, overall spatial patterns, localized hotspot, space-time modeling, multi-criteria risk assessment, network analysis, ecological niche modeling, and so many other techniques. But these are all a bunch of good spatial techniques for, again, characterize the primordial intervention. If you don't have a clear understanding of that, then it's really hard to achieve sustainability, because just the occurrence of a disease will make everything different. Just to say, to finish, this is a picture of when I used to be a farmer in the remote area of southern Chile. This is a wellboat that was the only means, the only way that I was able to leave this small island in Puerto Aguirre. So I was desperately waving my hands to wait for me and make sure that I can get into the port to leave that island. Beautiful, but very, very isolated. Again, this is a day-by-day activity. Network analysis, for example, for this kind of movement, which brings some risks, are also very important. So thank you so much for the invitation. I just want a few days for taking my plane, because I'm leaving Chile and the School of Veterinary Medicine at the Católica University to take a new position as senior lecturer of One Health and Aquaculture at the Global Academy of Agriculture and Food System at the University of Edinburgh. So much close, especially closely related, and that's mean that maybe we will have much more collaboration together. Thank you so much.